Welcome back. In this video, we'll explore how binary numbers work using a custom-built 8-bit binary display. Each bit is represented by a 3D printed block that rotates using a servo motor, flipping to show either a 1 or a 0. As we count up, the servos update the blocks to display the current binary value in real time. It's a hands-on mechanical way to understand how binary counting works. In the decimal system, we use 10 digits, 0 through 9. But in binary, we only use 2 digits, 0 and 1. Each block in our display represents one binary digit or bit. Each bit corresponds to a power of 2. The first block represents 1 or 0. The second is 2 or 0. The third is 4 or 0. The fourth is 8 or 0, and so on. When we add up the values of all the blocks showing 1, we get the decimal number they represent. When using a microcontroller like the Arduino-Uno, which is an 8-bit microcontroller, the highest number can represent in binary is 255, all 8 bits set to 1. The lowest number is 0, all bits set to 0. That's why, when we use functions like analog write-on pulse width modulation pins, the values must be between 0 and 255, because that's the full range of an 8-bit number. To count in binary, we add together the values of the blocks that are showing 1. Each block represents a power of 2. The first block on the right is worth 1. The second is 2. The third is 4. The fourth is 8, then 16, 32, 64, and finally 128. So if only the first block is showing 1, the value is 1. If the first and second blocks are both showing 1, we add 1 plus 2, which equals 3. If only the third block is 1, that's a value of 4. If the second and fourth blocks are 1, we add 2 plus 8, giving us 10. As we go higher, the blocks flip to show different combinations of 1s and 0s, and we just add the values of the blocks that are set to 1 to get the total in decimal. Here, you can see the binary counter cycling from 20. Each number is displayed for half a second, and the 3D printed blocks update in real time to show its binary equivalent. Watch how the pattern of 1s and 0s changes with each step. It's a great way to visualize how binary counting works in action. Great job! You've now seen how binary numbers work and how each bit represents a power of 2. If you have any questions, contact your instructor or click the chat button on the screen. See you in the next lesson.